Hello, welcome back to the JavaScript class. Today's topics are two popular algorithms, search and sort. Search problem is to find an element in the given storage, such as an array. Let's take a look at one example. The problem here is to find the value target in the given array values. The function should return true if the target is in the array values. So let's look at the code. We have a for loop. We loop through all the values in the array, and if value is equal to target, we return true. If we loop through the whole array, we did not find anything, we return false. So this algorithm is called linear search because it looks through every element in the array. And how to use this function is we call the search. The first parameter is array, and the second is the value you want to find. So let's try it. So this should return you to the true, and if you change to like 15, which doesn't exist in the array, it should return you false. Let's change our search algorithm a little bit. Instead of true or false, we need to know which position is the target in the array. So let's take a look at our modified solutions. So again, its search function takes array and the target value, and then we loop through every element in the array using another format of for loop. So we take this index I equal to 0 till to the last index of the array, and if we find the element, we return the index I instead of true or false. Then if we finish the whole loop, we cannot find this value target, we will return -1. Let's try it. Linear search is simple, and it could be a good solution if the array is not sorted. If the array is sorted, there is a search algorithm called binary search. It can give you the result much faster. Here is how it works. For example, in here we have an array has 10 elements. Let's say we want to search 23. The binary search is we start with the middle. So we have lowest index 0, highest index 9. We take the middle, it's 4. So we calculate the middle equal to 4. Then we compare 23 with the element in the middle, 16. If 23 is bigger, that means this 23 should be in the second half. Now, after that, the lower bound becomes to 5, higher index becomes to 9. Again, we take the number in the middle equal to index equal to 7. This is 56. So 23 is less than 56. Then we take the lower index 5, higher and 6, and the one in the middle is 5 itself. And we compare this 23 with the one in the middle, it's the same. Then we find it, we return 23. Now let's take a look at our code for the binary search. So again, we have a search function, take the array as first parameter and the target value as second parameter. And then we start with the binary search. The lower end is 0 and the high index is length -1. First, we have the termination statement saying, if low is greater than high, that thing is not right, so we return -1. And then we take the middle point. We use a math function called mathLand to convert from a non-whole number into a whole number. And then if we find the value in the middle, we just return the index. Else, we check whether it should be the second half or the third half. Then we change our low index, high end index accordingly, then call this function again. So in here, we are seeing the function search private is calling the search private itself. This is called recursive function. Now let's try it. So this gives you the 1. Now let's look at sorting algorithm. So before we start talking about sorting algorithm, let's look at a short video made by TED EDU.
One way would be to start at one end of the line with the first pair of books. If the first 2 books are in order, then leave them as they are. Otherwise, swap them. Then, look at the second and third books. Repeat the process and continue until you reach the end of the line. At some point, you'll come across the book that should be last and keep swapping it with every subsequent book, moving it down the line until it reaches the end where it belongs. Then, start from the beginning and repeat the process to get the second to last book in its proper place, and keep going until all books are sorted. This approach is called bubble sort. A second strategy would be to start by sorting just the first 2 books. Then, take the third book and compare it with the book in the second spot. If it belongs before the second book, swap them. Then compare it with the book in the first spot, and swap again if needed. Now you've sorted the first 3 books. Keep adding 1 book at a time to the sorted subline, comparing and swapping the new book with the one before it until it's correctly placed among the books sorted so far. This is called insertion sort. Here's a better idea. First, pick a random book. Call it the partition, and compare it to every other book. Then, divide the line by placing all the books that come before the partition on its left, and all the ones that come after it on its right. You've just saved loads of time by not having to compare any of the books on the left to any of the ones on the right ever again. Now, looking only at the books on the left, you can again pick a random partition book and separate those books that come before it from those that come after it. You can keep creating subpartitions like this until you have a bunch of small sublines, each of which you'd sort quickly using another strategy like insertion sort. Each round of partitioning requires about 1,280 comparisons. If your partitions are pretty balanced, dividing the books into 128 sublines of 10 would take about 7 rounds, or 8,960 seconds. Sorting these sublines would add about 22 seconds each. All in all, this method, known as quicksort, could sort the books in under 3.5 hours. That's why quicksort is one of the most efficient strategies used by programmers today. They use it for things like sorting items in an online store by price, or creating a list of all the gas stations close to a given location, sorted by distance.
Now let's look at some code to implement the bubble sort. So we take one parameter, its array to be sorted, and in here we have the for loop going through every element in the array. We check if the value is greater than the value coming to the next. That means this order is not right. So we swap it. How we swap it? So we assign I plus 1's position into i's element, and then we assign i's element into I plus 1. So if you look at it, in here we use another variable called temp to temporarily save the value of the value I before the swap. Why? Because otherwise you will, when you do the first statement, both I and I plus 1 has the same value. So the value in the index I was lost. That's why we need a temporary variable to save the value. And in the for loop, if this such swap happens, we set the swapped equal to true. If in the whole for loop there's no swapping, we will end the while loop. Let's give it a try. So in here we have 5 elements. They are not sorted, so we call the bubble sort, and then we print out the result. Now it's sorted. Remember, there are existing sorting algorithms in the array. So most of the time, you really don't need to implement your sorting algorithm. For example, in this case, we have the array. If we want to sort it, we can just define our compare function, say AB returns A minus B, and then we can call existing sorting algorithm and giving this compare function, and it should output sorted array. And let's try it. Now it's sorted. Now you may ask, okay, why do I need to define my compare algorithm? So let's check out. If we don't define our compare algorithm, if you call the a.sort, then it's sorted by alphabetical order. So it considers this every element is a string. That's why we need our own compare algorithm to make it compare by numbers, not strings. So let's look at this again. So if you think about it, the built-in sort algorithm is convert everything in your array into a string first, and then to compare. In this case, we don't want that. That's why we pass in our own compare function. Now, let's do some exercise. Again, you can pause the video before solutions are revealed. Question number 1. When will you use linear search instead of binary search? So we use a linear search if the array is not sorted. If the array is sorted, we can use binary search. And sometimes if the array is not sorted, because we need to search again and again, it will make sense for you to have the array sorted first and then to do the binary search. Again, for this question, the answer is you use the linear search if the array is not sorted. Question number 2. Which sorting method is the fastest? So the answer should be quicksort, then insert sort, and then bubble sort. So the answer is C. What are the values of A and B after the following code? So after the first 2 assignments, we have A equal to 6, B equal to 10, and then the third statement, we assign B to A, so both A and B become to 10. And then we have the fourth statement, B equal to A, really don't do anything because both A and B are already 10. So the final answer is both A and B are 10. If you recall, that's why when we need to swap two variables, we have to have another temporary variable. Complete the following code. So this function will check whether this array is sorted. So first we need to loop through all the pairs. So we from 0 to array length minus 2. So in the middle, the condition should be I less than values.length minus 1. And then we compare the pairs. If one pair is not sorted, that means values I greater than values I plus 1 will return false. If there's no such unordered pair at the very end, we return true. So this is the final answer. Let me explain why in the condition we should say I less than values.length minus 1, not values.length. Because in the if statement, we compare these pairs. So the last pair, I plus 1 should be length minus 1. That's why the last I should be values.length minus 2, which makes I plus 1 equal to value.length minus 1. If you use I less than values.length, the last I is values.length minus 1, it will make I plus 1 equal to values.length, which is not a valid index for this array. What is the output for the following code? So in here, we declare an array with two properties, name and price. And then we define our own compare functions, a.price minus b.price. Basically, it makes the compare function based on the price. And then we sort based on this compare function. So it will sort the pets by their price. And then we print out their names. So this name should be fish, cat, dog.